Using the graph, part A, we're asked to list the x values for which the function is discontinuous. Analyzing the graph, notice there's a hole in the graph at x equals 2, which makes this point of discontinuity removable. Recall that removable discontinuity is when we can make the function continuous at that point by redefining the function value, in this case, f of 2. And then also notice we have a break in the graph at x equals 2, where we have a vertical asymptote. This is non-removable discontinuity. Everywhere else the function is continuous. For part A, the x values where the function is discontinuous are x equals -2 as well as x equals 2. Part B, we're asked to give the intervals for which the function is continuous using interval notation. Well, if we know where the function is discontinuous, everywhere else the function is continuous. Notice the function is continuous to the left of x equals -2, which is the open interval from -infinity to -2 union. And then we have the interval from -2 to 2, or the open interval from -2 to 2. And then the function is also continuous to the right of the hole, which is the open interval from 2 to infinity. Part C, select all the statements below that are true for the discontinuities. First, we have the function is approaching infinity on one side and -infinity on one side of the non-removable discontinuity, which is where we have the vertical asymptote at x equals -2. Notice as we approach x equals -2 from the right side, the function values increase without bound and approach positive infinity. And as we approach x equals -2 from the left or negative side, the function values decrease without bound and approach negative infinity. So it is true, the function is approaching infinity on one side and negative infinity on one side of the non-removable discontinuity. So we'll go ahead and select this statement. Next, the function value is equal to 3 at its removable discontinuity. The removable discontinuity is where we have the hole. Notice the hole is located at 2, 3, but this does not mean the function value f of 2 equals 3. F of 2 is actually undefined because of the hole in the graph, and therefore this statement is not true. Next, the function is approaching infinity on both sides of the non-removable discontinuity. Well, we know this is false because we just showed in the first statement it's approaching positive infinity from the right and negative infinity from the left, and therefore it's not approaching infinity on both sides. And then for the final statement, the function is approaching but not equal to 3 at the removable discontinuity, which again is where we have the hole. And this is true. As we approach x equals 2 from the right, or the positive side, the function values are approaching y equals 3. And as we approach x equals 2 from the left, again, the function values are approaching positive 3, even though the function value is undefined at f of 2. So this last statement is true. I hope you found this helpful.